Good morning, sir. So my name is Wong Man Fai, TP063992. So this is my final prototype, which is the automatic smart rain detector system. So this is the LCD screen. It will be displaying all the information during the simulations, and then this is the sensors that is used to detect obstacles and insects. And then this is my microcontrollers using Arduino Unos, my buzzer right here, and then four different LEDs indicating 4 different weather conditions. And then this will be my rain sensors, and then this will be my tank lids. So let me get some wet tissues to demonstrate the wet weathers. Alright, so first of all, it's in dry weathers, so it will be in blue LEDs. Then when I touch the rain sensor, when it get a little bit wet, it will go into green, light rains. And then the next, if I apply more waters, it will go into moderate rains. So if I give even more waters, it will be heavy rains, where the tank lid will be opened right here. It will be opened and then showing tank rain opens, and then after 10 seconds, it will be showing a tank fill. Right, so if I take it off, it back into dry weathers. So that is the weather condition, 4 weather conditions. And secondly, so whenever I click this button, this one, it is an manual override button. So it doesn't care what weather is it, then in what condition it's under, it will still open until the user release the button. See, it opens with manual open status, then close when you release. However, if you are in heavy rain and there is an obstacle being detected, like here bug alert, the tank lid will not be open. Let me demonstrate you. So it's open, but when there is something detected on the sensor, it will be closed right here. You can still hear the buzzer going on, but the tank lid is not opening because there's something detected. And when I remove my hand and then I apply heavy rain again, it will be open, then close when something being detected. And this will be my entire system being demonstrated. Thank you.
Hello sir, this is my smart soil sensor system, and then the first thing, this is the Arduino, the main part, and also can divide the brand of this system. Because we have setting, if the tanky have the water, the system will just run it up. So now the tanky is no any water because the sensor no put inside the water. So the system will no run and show the low water refill tanky, and the buzzer will working. So after that we put the water sensor inside the water to detect the water have in tanky, so it will stop it. But now the salt is dry, so it will also to work the LED, the red one LED, to mention the user the solid is dry and you need to put some water, because now it's the manual mode, and also the buzzer with working. So now we put the soil sensor inside the soil, then it will stop to work the buzzer, and the LED will turn into the green LED to show the salt is the normal one. After that, and also we have used the yellow one to show the solid. If the wet solid, you can see now if the wet solid, so it will, the percentage is 75%. So if the wet solid, because the dry solid is 0 to 29%, and the normal one is 30 to 70. After the 70, that will be shown in the white salt, and the LED yellow one will be work lah. And then we also to put a button to change the mode. You can see now is the manual mode. After we put the button, then it will show with the auto mode. Auto mode, which will to help to the pumping the water to the solid lah. So you can see now it's the auto mode. And then if will become we take out the solid sensor, then it will show the solid. If the dry one, then it will start pumping the water normal 3 seconds. After that, it will checking the solid is still dry. If we pump again until okay, we check again the solid. Okay, until it become normal, it will start to pump the water lah. And also we have to use the AI instruction based watering which one is if the solid is very fast to dry. If you pump 5 seconds and check the solid again, you can see that. Yeah, you can see if pumping water fast dry. So if you pump for 5 seconds, after the pump, if you checking again, if the solid is still dry, then we pump normal 3 seconds. This because if the solid is too fast to dry, then if you need the more water to protect the pen, after he pump again, you will check the solid again to see need to pump or not. If you still dry, if you pump 3 seconds, not 5 seconds to save the water. And also because the Arduino not enough current to service to the pump, so we just use the relay to simulate the pump because if I connect with the pump, then if starting pumping, pumping the water, the system will not come back to checking solid. So we just the word is to use relay to simulate the pump. After that, I think in future maybe we can add the EP32 to solve this problem, or to make sure the power current is enough to service the water pump by maybe add more the battery or use the other main component, the Arduino or other team So that's all for my system. Thank you so much, sir.
Hi, I EP my subsystem for the development of smart crop monitoring and irrigation system is the temperature monitoring subsystem. This subsystem uses a DS18B20 temperature sensor to monitor the surrounding environment temperature around the plant area. The main component is Arduino UNO DS18B20 temperature sensor, LCD display, LED, buzzer, relay module, cooling fan, and the push button. Now I will demonstrate the subsystem actual work. When the temperature is below 29 degrees Celsius, the subsystem operates in normal mode, which the green turns, LED turns on, while the cooling fan and the buzzer remaining off. When the temperature exceeds 29 degrees Celsius, the subsystem enters the high temperature mode and the red LED and buzzer cooling fan turn on. This push button as a menu toggle stop function to temporarily stop the cooling fan and warning system during the operation. This subsystem helps monitor the surrounding environment temperature and protect the plant from excessive heat and water loss. That's all for me. Thank you.
Good day, everyone. My name is Lee Jingwen and my TP number is TP077601. So now I will be sharing my individual subsystem, which is the Smart Sunlight Detection and Solar Shade Control System. So in this subsystem, I am using a Maker-Uno as the main microcontroller, and also using a LDR sensor, a buzzer, a LCD display, a push button, a RGB LED, and a servo motor here. And here is the solar panel. And the last one will be the Wi-Fi module ESP8266. So now I will start demonstrate the subsystem. Currently, the system is under normal sunlight condition. The green LED is turned on and the buzzer is remain off. And the LCD will display Optima, and here is showing the light percentage, and this one is the angle of the servo motor, which is 90 degrees. And here it will also showing the same value here. So the next mode I want to show is the night mode. So when I cover the LDR, the blue LED will turn on and the buzzer will also remain off. The servo motor is also not being changed. So the last condition I want to show is the too hot condition. So when I open the light, the red LED will turn on and the buzzer is also active. So when I push the push button, the buzzer will be mute. And also, the servo motor here will be set to 0 degrees for shade protection. So you can see here, the angle is 0, the light is 91, and the system status is too hot. Here we're also showing the same. So that's all for my subsystem. Thank you.
Good morning, sir. So this is our entire automation systems. So start off, we have our water irrigation system using the soil detections, and then we have our rain detectors right here to perform controls over other systems later on. Then this is our temperature system where it detects the temperature, then provide an output. And then this is the final system with a Wi-Fi module which we can upload to the mobile apps later as shown right here. So every necessary details is on the phone right now. You can see the pump is off, the lid is closed, and then the status is in optimal. And then it also have the function of the solar panels where we will adjust based on our weather setting. So we go back to our main detection first, which is the rain detections. So if there is no rain or dry weather, every system will function normally. I can show right here the soil will be going on pumping if the soil is detected dry. It will go on and pump the dry soil for 5 seconds. You can see in the relay right here, and when we go back in, the system function, everything goes on. And then for the temperature part, the system will goes on buzzing if the temperature goes too hot. But if the system goes too hot, it will goes on buzzing lah. Okay, like the normal systems. And then the solar panel will stays on this degree when the weather is too hot. And then when it is in heavy rain, every system will shut down as shown right here. Wait, put more water. Okay, so when in heavy rain, the system will be paused. Even if the soil is dry, it will not function. It will not pump any water. As shown in the relay right here is in red light, so it is not pumping water. So the entire system has been shut off to save resource. Then we move to the temperature system. It will also be shut off entirely to save up resource of power or energy. Even if the temperature is too high, it will not give any buzzing sounds. And then the solar panel will rotate to an angle suitable for it to obtain its functions. It will not be affected by the rains. And the LCD will also show heavy rains, which is the communication across our entire systems. And we can also see in the rain status right here, the tank lid is open to store in waters, and in heavy rains, the font is too long, so we cannot see, but you can see the H letters. And that's mainly about all our system.